Okay, everybody. So this is lecture one for week three. And what we're going to be going over primarily is going to be this first variables set of lecture slides under lecture one here. Actually, we're not going to be doing Zybooks, I don't think. So I should probably delete that. Um, yeah. So with that said, let's go ahead and get started. So this set of lecture slides covers stuff that we already covered, but then there is a little bit of new stuff. So we'll start here and hopefully we'll have time to look at the second one. If we don't, then that's going to be covered in lecture two and also possibly in lab two. It's the material from lab two. All right, with that said, let's go ahead and get started. We're going to be looking at variables.pdf here. Okay, so a lot of this stuff we already know, and I'm going to skip through it pretty quick. So they talk about the flow of a program and code structures in Java. And let's see here, do something, do something. All right. So we get to the point where they want to talk about variables, and there's some details here. So we need variables to hold our data. And up until now, we've been using integer variables. And so if I go over to Eclipse here, which is right here, we've already learned that you can do something like this, like int, and it'd be like some number, right? And we can say 10, right? And now some number is now equal to 10. And so that's a variable, right? And this is just more details about how variables work in Java. So we can just scroll through and look. So we need to hold the input to the program so that you can access it later. Variables are used to hold the data, and there's two types. So this is like a exam type question. What are the two types of variables, or what do they do? How are they different? That kind of thing. So the two types are primitive types and reference types. And so primitive types, as it says here, are for simple values that are kind of built into Java. And there's a list of them, I think, 2 slides away from where we are now. But they're for simple things. So some of the types are listed here: int, double, character. I'll put a couple here. So we already have an integer, right? So a double, and I'll just call it like x, is a decimal number. So doubles could be like 3.14, right? Which we know that an integer can't be. So you use whole numbers for integers are whole numbers and doubles are decimal type values, right? Another type is a character. And a character, sometimes people will say char because it looks like char, is just one letter on the keyboard, basically. So something like A, right? That's a character. And we'll get into using these later on because there's times where you need to take apart a word or look for a particular letter or something in a word, and those are characters. Now, it's not just letters, because, for example, a space is also a character, and a question mark is also a character. Semicolon is a character, comma is a character, parentheses is a character. Everything on the keyboard plus some other stuff is a character, right? So, yeah, those are characters. And they're one of the primitive types. And there's a list of them that we're going to see. Now, a reference type, it says here, is composed of many primitive types that describe a single object. And we don't get into using those until later on, for the most part. We have seen some. So we've seen scanners, right? Um, import Java dot util dot scanner. Oops, not all uppercase, right? We've seen like scanner SCNR equals new scanner system.in, right? And so a scanner is a reference type. And you'll notice that the way that Java deals with them in here in the editor is a little bit different. It highlights them a different color. Oh, I didn't give this character a name. Okay, now we do. Um, so you can see that it highlights them a different color. So the primitive types were highlighted here in this kind of orange brown color, and you can see that the scanner was highlighted blue. Another reference type is a string, which we also have not used, but I can say my string, and it could just be my name. Does it have to be all uppercase? No, I just hit the key. Okay, so again, you can see that it's highlighting them a different color. There's other things you can notice about them. One thing you can notice about them, and this is described on the next slide, so we'll probably just go there. It's not, but we'll get there. So primitive types, there's a bunch of them. And so there's four types that can store integers, which are whole numbers: byte, short, int, and long. There's two types for decimal type values: float and double. And you'll notice it says double is more common, and it says integer is most common. So we're going to use int a lot, and we're going to use double a lot, and the others we're not going to use pretty much at all. So they're there, but we're not using them. There's the character type, which we already mentioned, and the Boolean type, which you probably have not heard of that word before, but a Boolean is a type that can be either true or false, and that's it. So there's only two possible values for a Boolean. Now, here's some more information about them. Um, so we have the type here. So a byte is an integer, and it uses 1 byte of data. And so 1 byte is 8 bits. So it looks something like, let's type it in Eclipse. This is not really a place to type, but 8 bits is like a 0 or a 1. So if I go like 1, 2, 3, 4, 5, 6, 7, 8, this is a byte. So 4 zeros and 1s, and then 4 zeros and 1s make up 8, and 8 is 1 byte. And that's just an example of one. I just typed some zeros and ones. Now, the thing about a byte is that because there's 8 bits and every bit can have two possibilities, there are 255 possible bytes, 256 possible bytes, I'm sorry. Um, so there's combinations of zeros and ones. There are 256 possible combinations of 0 and 1 if you have 8 of them. Why 256? Because that is 2 to the 8th power. So there's 256 possible values for a byte, and a normal byte uses those 256 possible values by splitting them in half so that half of them are negative. So 128 is half of 256, and half of them are positive. Um, but then one of them has to be 0. So that's why it's not negative 128 to positive 128, because that would take 257 possible values. So there's one less than you think. And with 1 byte, you can represent numbers only between negative 128 and positive 127. So that's too limiting, right? Like if all of our numbers had to fit between negative 128 and positive 127, then that would make it hard to do a lot of programming, right? There's just times where you need bigger numbers than that. And so if you do need bigger numbers than that, then instead of using a byte, you could use something called a short. So a short takes up 2 bytes. So now we have twice as many zeros and ones, right? So if 1 byte is 8 bits, 2 bytes is 16 bits. And so with 16 bits, you can make roughly 64,000 possible values, actually 65,000 possible values. And it splits them in half in positive and negative again. And so with 2 bytes, you can represent numbers from negative 32,000 to positive 32,000 something. And so on, right? And so you move up to the integer. Integer takes 4 bytes. That's 32 bits. and the numbers can range between negative 2 billion to positive 2 billion. And so negative 2 billion to positive 2 billion is pretty much what, enough for a lot of things. And so that's what we are going to be using for this class for the most part, right? If you somehow needed a bigger integer, then you can move to a long, and a long would be twice as big again. And so you can make up a lot of very, very, very large numbers out of a long. Okay. And then the floating point numbers, which are the decimal numbers, work the same way. However, they don't bother with like a 1 byte or 2 byte format. Um, in Java, we have a float, which is 32 bits, and we have a double, which is 64 bits, and that's what we use by default. So doubles are 8 bytes or 64 bits, and you can represent numbers between negative 1.7 times 10 to the 38th to 4.9 times 10 to the negative 324. So very, very large numbers to very, very small numbers can all be represented with a double. Um, and so these are generally enough to do even scientific computations, except in very rare cases. So we just kind of default to using doubles for these decimal numbers, and we're using 64 bits for them. That's what 8 bytes is, because, well, honestly, because our computers are 64-bit computers. So it's the natural data type for the processors that we're using. Now you might ask, why are we using integers then, which are not 64 bytes, sorry, 64 bits? Um, Compatibility with old software, pretty much. So yeah, so these are some of the primitive types. So all of these are built into Java. And something you'll notice is that they all start with a lowercase letter for their name: byte, short, int, long, float, double, character, and Boolean. We already mentioned characters. Characters are one basically keyboard character, although Java uses Unicode, so they're Unicode characters, and we'll learn more about that later on. Um, the thing about Unicode is that in the history of computers, right, when they first started doing text, they only worried about the keys that you would need on a keyboard for like an English language keyboard. And so they didn't need very many keys, right? You needed, there's 26 letters, but then lowercase and uppercase makes it twice as big. And then there's numbers, and then there's symbols. And, there's still less than 100 things that you would need um, on those old computers. But as soon as you start doing other languages, then suddenly, you don't need 100 different symbols to type in, Chinese or Japanese or Korean or Vietnamese, or there's a lot of languages that need a lot of symbols, right? So they couldn't get away with just 100 symbols or so. So they had to come up with a system that would handle every language, and that system was Unicode. Um, but we can still think of it as being basically the letters on the keyboard, at least if we're doing English. Booleans are true and false values. Um, so you only need one bit for that. So 1, 0, or a 1, because a true can be a 1 and a false could be a 0 internally to the computer. So very small. And those are your primitive types. So what do we use? We use int, we use double, and we use character and Boolean when appropriate. So actually, these are almost all the ones that we would be using right here in one place. We can add a Boolean. Boolean uh, is hungry equals true. I am hungry. Okay. Um, so you can notice that the reference types all start with a lowercase letter. And sorry, I wrote reference type twice. I don't know what I'm doing. Primitive. You'll notice that the primitive types are all lowercase letters. And you'll notice that the reference types have uppercase letters to start with. That's because these uppercase letters, in this case, these are both classes, which is one of the types of reference types that we could have. Um, but you're always going to see primitive types as lowercase and color coded to indicate that, they are. And reference types are classes and other things. I misspelled reference. Okay. So here's examples of primitive types. So, integers are whole numbers like these. Floating point, that's like our double. Our decimal values like these. Notice that they write 5.0 here. Um, we're going to get in the habit of writing floating point numbers this way. You wouldn't want to write just 5. You would want to write 5.0. And I'll show you why when we get to that point, maybe in this lecture, maybe in the lab video. Character types, as I said, are characters on the keyboard. So lowercase letter, uppercase letter, pound symbol. This is a space. Space is also a character. Boolean, those are true and false, as we said. Notice that it's lowercase, true, lowercase, false. That's the case for Java. Some other programming languages capitalize the T and F, but not us. All right. So you should think of variables as places to store data, such as numbers and letters, and they're implemented as memory locations. So internally to the computer, your RAM has a bunch of numbered memory locations, and basically a variable is just a place in memory to store something. Okay. Um, what do you store in a variable? You store a value. So looking back at Eclipse here, right, the variable is some number and the value is 10. For the double here, X is the variable, the value is 3.14. My character is the variable, M is the value. Is hungry is the variable, true is the value, right? Same thing done here. My string is the variable and Greg is the value. So variables can be changed, right? Like I can say that some number is 10 up here, and then down here I can say some number equals, 99. That's perfectly okay. So up here it's 10, down here it's 99. Perfectly fine. So you can change those values. Now there's rules for naming them. So some of them are rules and some of it is just advice. So you should choose names that are helpful. So you should name a variable count or speed, not C or S, for example. When you come back later and you're trying to read your code, you're not going to remember what C stood for or what S stood for if there's multiple things that also start with S. So it's important to use whole words for your variables when possible. Sometimes it does make sense not to. Like if you're doing math, sometimes you want to use a variable X just because that's what we use in math, right? So it makes sense sometimes, but as a general rule, you should use full words. Now, when you declare a variable, you have to give it a name and you have to have the type. So you say int, and then you have the name of an integer, right? And so I did that in every case here, right? Int some number. So this is the declaration, but it can be split up into two pieces here. So if you do this, int some number, and then I do some number equals 10, this is allowed. And what we're doing here is that this top line is what we call declaring a variable. So we're declaring a variable here. And on the next line, we're putting a value in it. When you put a value in it, that's called initializing. So you're initializing a variable there. And so in order to use the variable, you need to declare it first, and then you have to initialize it with some value. So I initialized all of these values, except for one. Down here, scanner SCNR, that is not initialized. If I did this, which we do when we want to read from the keyboard, now this is initialized. So when you just have the variable type and the name, that's called declaring the variable. So that's the declaration. And when you give it a value, that's the initialization. And you can do that for any variables. Now, if you do them both on the same line, like this is declaring the variable double X, but then we also gave it a value that's declaring and initializing. So you can do both at the same time if you want. So this right here is showing the declaration of a couple of variables. You can declare more than one variable per line if you use commas. So I have one X value here, right? But I could say X, Y, Z. And then we declared three variables all at once. But they're not initialized, so you'd still have to put in values if you wanted to use them. And as I said, we should type them in as decimals if we intend to use them as decimals. So even -6 here should be typed in as 6.0, not just 6. Or there's reasons why that's important. All right. So a variable's type determines what kind of values it can hold. Yeah, so you can't, if I run this code, it should run. I don't think we're doing anything weird. It does. You don't see it, but it ran. Um, if I tried to go up here to this integer and I try to put in like some decimal and I try to run it, it's not going to let me because it says unresolved compilation problem, type mismatch, cannot convert from double to int. Um, so yeah, you can't stick a floating point decimal value into an integer. It just won't work. You could put 78 into an integer, right? But you couldn't put 78 point something. So the type determines what you can put in the variable, and a variable must be declared. Okay, cool. Um, Syntax, here's some examples. Yeah, we've seen examples already, and you've seen examples in your own code. Now, the rules for naming things is that classes have to begin with an uppercase letter, and primitive types, they contain lowercase letters. And you actually name classes all the time because every time you make a new project in Eclipse, you're creating a class, right? Like this one, I'm just typing in here just so I have a place to type. But this was called lab2. And you will notice that the file is called lab2 with a capital L. And here it says public class lab2 with a capital L. When you create a project, you have to, well, your project can be created with anything. So, right, if I go Java project, I can go, here is a project. Um, I can create that, and that's okay. But inside there, if when I want to actually add a class to it, and I go, new class, and I have to pick a name, I could not name it like that. I would have to pick something that starts with an uppercase letter here. So I can go like my project would be okay. And you can see the finish button will let me press it. If I change this from an uppercase M to a lowercase m, it probably, oh, I guess it will. It let me do that, but it should not have, I think, let me do that. Some versions of Eclipse won't let you do that. Um, but you should be naming your classes with an uppercase letter, even if it let you get away with it the other way. Um, Anyway, scanner and string down here were classes, and they are uppercase letters as well, in addition to all of the projects that you make, which also have uppercase letters for the classes. Primitive types are lowercase, which we mentioned. Um, Variables, so this is important. It doesn't matter. So the types, classes start with an uppercase letter, like string. But the variable names should be lowercase, start with a lowercase. That's why if you look over here in my example again, you'll notice that the type, oops, too big. The type for this is a scanner and it has an uppercase S. But the name of the variable was SCNR, which is lowercase, right? That's typical. Same thing for the string here. String, the class, has an uppercase letter on it because it's a class, but this particular string, this is a variable name, and I called it my string, um, has a lowercase m. So the names of the variables start with lowercases, but the actual types, if they're classes, are going to be uppercase. So there's uppercase for the type, lowercase for the variable name. So they're telling you that there. Now it says multi-word names are punctuated using uppercase letters. What they're talking about is this kind of naming system where you start with a lowercase letter, but if you wanted to say my balance, then every time you go to a new word, you uppercase that word, or sorry, you uppercase that letter. So like my balance, you uppercase the B so you can kind of see the separation between the two words there. And they did that up here. I think I'll scroll back to find it. Like if you look at the names of all these variables, they follow that rule, right? Like style choice, it's two words. So they start out with a lowercase letter, like we said, but then when they switch to a new word, they uppercase it. Number of checks. So uppercase O, uppercase C. Um, joint or individual, lowercase j, uppercase O, uppercase I. So you just write your words together, and every time you switch to a new word, you uppercase the letter. So that's what they're talking about there. Identifiers. So identifiers are the names of things, such as a variable. The rules are that you can use letters, digits, underscores, and dollar signs, but it says has special meaning, so don't use dollar sign. Um, you want to use letters, digits, and underscore when you feel like it. First character can't be a digit. I think we've learned this before. You can't have the first letter or the first character be a digit because if you were to do something like this, int 3 some number, um, that confuses Java because it sees the 3 and it thinks you're typing in a number, but you're not. You're typing in like the name of a variable. So it won't let you start with a number. It's okay to put a number in there. It just can't start the word with a number. All right. Um, so your variable names can be long if you want them to be. I mean, they probably shouldn't be too long, but they could be. Java's case sensitive, so like all lowercase stuff, stuff with a capital S, and all uppercase stuff, those are all different, right? So Java will if you type the wrong case, Java will not know what you're talking about. So you have to pay attention to what case everything is. You probably have seen this before because when you're doing things like typing in scanner, for example, you might accidentally type a lowercase s. And if you do, then it won't work because this scanner is an uppercase. There's certain words you're not allowed to use. A lot of them are just what it comes down to is if the word is already used for something in Java, you can't name your variable that. Um, should be obvious when you think about it. Like if we're looking at like this integer here, some number, you can probably see that it might be a problem if you said, I want an integer called double, right? Won't that be a problem? Because if you made an integer called double, how does Java know the difference between this double and the double type, right? So that won't work. Also, like public class, right? Those words are used in creating just the structure of a Java program. So you can't name an integer public because again, that word is already reserved. It's doing something else. You can't make a variable named the same thing or it'll confuse Java. You also can't make a variable called class for the same reason, right? So all these things are like this, where you can't use a word if it's already used by Java for something important. It's not really crazy concept. Now, that's kind of too bad, right? Like you can imagine some scenarios where like class would be useful, right? Like what if you were doing a program that was related to school, right? Then, maybe it makes sense to have a variable that was called class, but you can't do it. You just have to call it something else. You could call it class one or class two or something. Just can't call it class by itself. Assignment. So again, we've already been doing this, but the equal sign is called the assignment operator. And in order to use the equal sign, it's important that you understand that it's always on the left side of the equal sign, only one variable. So like amount equals, right? Variable is amount. First initial equals, score equals, eggs per basket equals, right? It's always one variable on the left, and that variable is where you're going to assign, where you're going to store an assigned value. So on the left-hand side, you say amount and then equals, and then the right side is an expression that can be evaluated. So it doesn't put it in those words there, but it's always variable name equals, and then some expression over here. Okay. And the expression can be more complicated, right? Like if I say x equals, um, I can't really do anything else on the left-hand side. But on the right-hand side, this could be, 3.0 times, uh, I don't know, the sine of 4 plus the log of 3, right? Like something like that would be allowed. So the right-hand side of the equal sign can be relatively complicated. This wouldn't actually run, by the way, because I didn't type it right. But this kind of thing is okay on the right-hand side. The right side can be complicated. It just needs to be able to be evaluated. So like if the computer knew what three times sine 4 plus log 3 is, that would just be a number, and that number can be assigned to the variable x. So it's always variable on the left, equals, and then on the right, some more complicated, potentially expression. So back over here, these are just examples of assignments. So amount is 3.99, first initial is W, score is number of cards plus handicap, so both of those must be numbers. Eggs per basket equals eggs per basket minus 2. Um, that's perfectly okay. In math, this doesn't make sense. Like math equals, like if the eggs per basket was 10, for example, how could it possibly be equal to the eggs per basket minus 2, right? Like if eggs per basket was 10, this would be saying 10 equals 8 in math. But that's not what's happening in Java, right? Because in Java, equals is assignment. So if eggs per basket, actually, I'll show you over here. If I had a variable, so like just say int y, for example, and we'll make it 10. If you do something like this, y equals y minus 2, then what happens is y is 10. So if you figure out what's happening on the right-hand side here, if y was 10, then y minus 2 is 8. And then that 8 is going to be stored back into the y value. So if I modify this to actually print this out, system.out.println, I'll just say y equals, and then we'll do plus y. So if I run this, it's going to print 10. Oh, I have an error. Let's go fix it. I already had a y up here. That's why. So if I run this, it prints out y equals 10 because I made y equal to 10 and then I printed out the y value. But if I were to print it out again after I run y minus 2, I'm going to get 8. Um, so y starts out as 10, but then when you do y equals y minus 2, y minus 2 is 8. 8 gets stored back into the y variable, and then when we print it out, y is 8. So when you see an expression like y equals y minus 2, you should understand that that's just subtracting 2 from the y value. And you just get used to seeing that in programming, right? So you just look at this and say, what's happening here? Oh, we're subtracting 2 from whatever eggs per basket was. Okay. Um, we've talked about this stuff before, I think, like what would be okay for variable names. This one's fine. This one's no good because you can't start with a 1. You can't name a variable with a dot. You're not allowed to put a dot in there. One of the earlier slides said that. You can't name a variable long because long is already a primitive type. You could name a variable time limit, but you shouldn't because we were told that we should name variables with lowercase variable names to start with. So we wouldn't want a capital T there. Number of windows is fine. Could you have two different variables, one called my variable and one called my variable, but with different capitalization? Yeah, you could. That's fine. Um, okay. So it says where do you declare variables? Just before it's used or at the beginning of the section of your program. So um, a lot of times what we'll see is people declaring all their variables at the top. So you'll see like this kind of thing, right? You'll see like int XYZ scanner equals scanner SCNR equals new scanner system.in. And then if you want to read a number from the keyboard, then you do like X equals um, SCNR dot next int, right? And so this is going to read a number from the keyboard. And so it's waiting for me to type a number. So I say like 8, and then we're done. Um, so this is like all your variables up here. And then once you're done, then we do stuff after all your variables were defined. Um, that's a very common way to do it. Sometimes you see people not doing that. And what they'll do is like the scanner still needed to be defined up there. But what they could do is they can just say, well, if I want to read an integer, how about I just declare it right here? I'm going to declare the variable right when I'm about to do something. So then if I need 3 of them, for example, I can just do that 3 times and I can have, 5, 3, 1 for X, Y, and Z. And so this is declaring all the variables when we're using them rather than up at the top. And that's okay. But the problem is when your programs get long, right? Like if I'm just going to go to a later lab here. Um, like here's some code from, so weird. Here's some code from 2 semesters ago. So this has a lot of lines. Well, 60 lines. I guess it's not that many lines. But this has more lines of code in it, right? And so if the very first time you used a variable was down here, it would be hard to look at that and see that. And so that's kind of the issue here is that if you have too many things going on in a long section of code, then how are you going to keep track of all the variables? It'll be hard to find them. So that's kind of the point there. Um, you can organize them. So declare variables up top and then do other code is recommended, but not required. Oh yeah, this is interesting. So let's do this. So we don't need a scanner anymore. So let's say int x equals, I'm gonna say 10. Okay. And then I'm gonna print it out and we'll just say x equals, and then plus x. And of course, it should print out 10. That's really annoying me the way that the console is working here. Go down here. So we printed out x and it was 10. And we have previously mentioned that if I did this, x equals x, let's say minus 3. Okay, and then we're going to print it out again. Then you should be able to predict that this is going to print out a 7, right? Like that. Because we started out with 10, but then we subtracted 3. But sometimes people don't like doing this. For x, it doesn't matter. But what if your variable had a long name? Like this was like my favorite number, like that. Um, if your variable was called my favorite number, and then you wanted to do this, it'd have to be my favorite number equals my favorite number minus 3. And that's like a lot of typing, right? I guess I didn't get it everywhere. That would be a lot of typing um, when you had to do my favorite number equals my favorite number minus 3, right? So you had to type it twice. So people are lazy, so they don't want to do that. They don't want to type the number twice. So there's actually shortcut. So um, instead of doing like x equals, I'll do x plus something. Instead of doing x equals x plus 3, I'll do plus 3. So it's 13, right? Instead of doing that, you can basically type it like this, plus equals 3. So that's like just a weird programming thing that Java has. C++ and C also have it. Other C-like languages like C# also have it. But this is just shortcut. So I get 13 here anyway. And this plus equals syntax also works for multiplication and division and subtraction. So like if I change it to minus equals, that's just going to subtract 3 from whatever x was. So we get 7 now. And if you do times equals 3, then you're going to get 30. So times equals 3 will multiply by 3. And if you do slash 3, slash equals 3, that's going to divide by 3, which is going to be 3. 3 because we're dealing with integer values. Like if I were to put, like, let's say, I'm going to pick a different number. I'm going to say 8. 8. No, not 8. I want this to be 8. Then I want to divide by 3 still. So, well, if I put a 2 first, sorry. Um, if I put a 2 there, right? 8 divided by 2 is 4. So you get 8 and 4. But if I tried to divide by 3, I'm going to get 2 there. Because when you divide 8 divided by 3, you actually would get 2 and 2/3, right? So technically it should be 2.6666666, right? Something like that when you divide by 3. But because this is an integer variable cannot store a decimal value. So when you do 8 divided by 3, it should be 2.6666. But the entire end is just cut off and you just get 2, nothing after the decimal point. So that's what's going to happen whenever you're dealing with integer arithmetic and you do division. You throw away the decimal if there is one. Regardless, that's not the point, right? The point was to learn about this syntax. So times equals 3, multiply by 3, plus equals 3, adds 3, and minus equals 3. Oops, not debug. Subtracts 3, minus equals 3. So this kind of thing is helpful, and programmers use it all the time because it slightly less typing, and people always choose to type less. All right, so that's going to be it for this lecture. There's going to be another video coming that's going to cover some of the Zybook stuff, but also you'll need to, like, some of the stuff that's in this lecture here called variables part 2, we didn't look at today, but it is going to be necessary for lab 2. And so you'll need to look at that video before we do lab 2. Having said that, this video probably also explains it. So um, the video walkthrough for the lab probably covers a lot of the same material, but the next lecture will also cover some of this material. So anyway, that's going to be it for now. I will talk to you guys later. Need to figure out where the stop button is.